Hi everyone. We're going to look at the most difficult part of transformations, and that happens when we have multiple transformations on the input. So let's say we want to take a function and we want to transform the function so that the function is now f of 2x minus 5. You'll remember with vertical transformations, we always did a vertical stretch first, and then we did the up or down movement because we were following the order of operations, and multiplication always comes before addition and subtraction. Now with the input transformations, you'll remember the saying x lies. So not only are the signs backward for moving left and right, not only are the horizontal stretches and compressions based on the reciprocals, but the order of operations that we do the transformation is also backwards. So that means we would move left or right first, and then we would do the horizontal stretch or compression. So for this function, first we would move right 5 units, and then we would do a horizontal compression by 1/2. So let's say we had the point 3,7 lying on the function, and we wanted to see where the point would move to on f of 2x minus 5. So first we would take the point and move it 5 units to the right, which would put us at 8, 7. And then we would do the horizontal compression by a factor of 1/2. So we'd take 8 and we would multiply 8 by 1/2, and that would put our new point for the transformation at 4, 7. One of the things we're sometimes especially interested in with this is what would happen to the y-intercept. So let's look at the point at 0, 8. And so where would this point that was originally the y-intercept move to? Well, first we would move it 5 units to the right. So that would put it at 5, -8. And then I would do the horizontal compression by a factor of 1/2. And so that would put the point at 2.5, -8. And it's no coincidence that we can just take 5 divided by 2, and that's going to tell us where our y-intercept's going to move to. And that's going to be especially useful later on when we look at something called phase shifts with our trigonometric functions, and to be able to help us know where to start drawing these trig functions. So a couple of other considerations. If you're a more comfortable person with algebra, this might be a little easier for you as far as figuring out how to move these values. So all I have to do is, here's my input, which was 2x minus 5. And what I want is I can take my input and I can set it equal to the x values. So watch what's going to happen here. So I do 2x minus 5 equals 3. To solve that, I just add 5 and divide by 2, and I get x equals 4. So that's one thing I can do also to show that my new point is going to be at 4, 7. And same thing, 2x minus 5 equals 0. Just add 5, divide by 2. I get x equals 5 halves, or 2.5. And that's where my point was before as well. And then one final note, a little different way to look at this. If I were to take the 2 and factor it out of 2x minus 5, I would have 2 times the quantity x minus 5 halves. And so I could still do the solving like I did before. And some people might like that better. The advantage of doing it this way is if you factor out the b value, then it keeps it consistent that you still do your stretch or compression first, and then you would do your translation second. So with the y-intercept, it's really obvious that there's not going to be any horizontal stretch for the point on the y-axis, but I will move the 5 halves to the right. And with this point here, 3, 7, so in this case, first I do the horizontal compression by a factor of 1/2, which would move the point to 3 halves, or in other words, 1.5, 7. And then when I add 2.5 or 5 halves to that, that would give me 8 halves, which would be 4, and puts my point at 4, 7. So there's a few different ways you can look at these. One of the things you'll have to do is decide which of these makes the most sense for you. And this is just an important knowledge base that you need to be able to work with some of these trigonometric functions later on. So try it yourself now. Take these 2 points on the graph of f and find the new points that they would move to on the graph of f of 1/10 x plus 3. So I know I have a horizontal stretch by a factor of 10, and I also know that I'm going to move 3 to the left, and x lies, so we're backwards. So first I move 3 to the left, which puts me at -3, 2, and then I would multiply that by 10, which would put me at -30, 2. Or I could solve 1/10 x plus 3 equals 0, which would just be 3 times 10. Or I could factor it like so. So if I factor out the 1/10, left inside the parentheses would be x plus 30. And so first I do the horizontal stretch of 10, which does nothing because it's on the y-axis, and then I move 30 to the left. So same thing using any of the methods. I will end up at -40, -2 for the second point here. So this is one of the most complicated things, I think, to grasp as far as the transformations of functions. So you'll want to do lots of practice, and what you'll want to do is pick one of these ways to deal with it that makes the most sense for you, and then use it consistently.